I chose to analyze the physics in two scenes from the movie Speed. The first scene that I analyzed was a falling elevator. In this scene, a bomber looking for ransom blows off the cables of an elevator. The emergency brakes stop it from falling, but the bomber threatens to blow those off too if he doesn't get $3 million within the hour. Two cops manage to fasten a cable to the elevator just as the bombs detonate, which again stops the elevator from falling. During this time, the cops free the hostage just as the cable breaks, causing the elevator to fall 22 stories and crash on the ground. In this scene, after the final cable holding up the elevator breaks because the force due to gravity from the elevator put too much stress on it, the elevator free falls 66.88 meters to the ground with an acceleration due to gravity of 9.8 meters per second squared in about 10.96 seconds. In order to see if the elevator fell in the correct amount of time, I used a stopwatch to time how long the elevator took to hit the ground in 5 trials and averaged these times to get about 10.96 seconds. In order to tell if this time is correct or not, I first calculated the distance the elevator fell. In this scene, it shows that the elevator was on the 22nd floor. For this information to be useful, it had to be converted into meters. I found that 1 floor is equal to 10 feet and that 1 foot is 0.304 meters. I multiplied 0.304 meters by 10 feet to find that each floor is 3.04 meters tall. I then multiplied this by 22 floors to get a total height of 66.88 meters. Now that I knew the distance, I used the fact that the initial velocity of objects in free fall is always 0 meters per second and that objects in free fall accelerate at 9.8 meters per second squared to find the time the elevator should have taken to fall by using the equation d equals VIT plus 1/2 AT squared. I plugged in all of the variables and solved for time, which was 3.69 seconds. In order for this scene to be correct, the elevator should have fallen in this time. The next scene I chose to analyze was the freeway bus jump, where in another attempt for ransom, the bomber attaches a bomb under a bus that will detonate if the bus drives below 50 miles per hour. The bus enters an empty freeway but is not notified of a 50-foot gap in the road a few miles ahead of them. With nowhere else to go and being unable to stop, the bus is forced to try to jump the gap. The bus speeds up before jumping and safely clears the gap, even managing to stay above 50 miles per hour, saving all the passengers inside.
Everybody hold on!
During this scene, the bus accelerates to a greater velocity and jumps the gap from one point to another that is equal in height without gravity pulling it down. In order to test if the bus should have made the jump, I first converted the length of the gap, which was 50 feet, to meters by multiplying 50 feet over 1 by 1 meter over 3.28 feet to get a distance of 15.24 meters. I then converted the initial velocity of the bus before the jump, which was 67 miles per hour, to meters per second by multiplying 67 miles over 1 hour by 5,280 feet over 1 mile by 1 meter over 3.28 feet by 1 hour over 60 minutes by 1 minute over 60 seconds to get a velocity of 29.96 meters per second. I then found the time in the horizontal direction that the bus took to cross the gap by using the equation time equals distance over velocity, where the distance was 15.24 meters and the velocity was 29.96 meters per second, to get a time of 0.51 seconds. I then calculated the distance in the vertical direction that the bus moved by using the equation d equals VIT plus 1/2 AT squared. Time in the horizontal direction is the same as in the vertical direction, so I plugged in 0.51 seconds for time along with 9.8 meters per second squared for acceleration, because in the vertical direction gravity is the only force acting on the bus, and 0 meters per second for initial velocity to get a distance of 1.27 meters. This shows that during the bus jump, the bus fell 1.27 meters, so it would not be able to jump from one side of the freeway across the gap to the other side that was the same height. In order for the bus to clear the gap, it must go over a ramp with an incline of 9.59 degrees. I found this by first finding the initial velocity in the vertical direction that was needed for the bus to jump 1.27 meters high at the top of the parabola. To do this, I used the equation Vf squared equals Vi squared plus 2AD, where the final velocity equals 0 because it is at the top of the parabola. The acceleration is equal to 9.8 meters per second squared, and the distance is 1.27 meters, as it must travel that high at the top of the parabola to clear the gap. After substituting in these variables, I solved the equation and got an initial velocity in the vertical direction of 4.99 meters per second. I found the angle that the ramp should be positioned at for the bus to clear the gap by using the trigonometry equation theta equals the inverse sine of opposite over hypotenuse, where the opposite is 4.99 meters per second and the hypotenuse is 29.96 meters per second, to get an angle of 9.59 degrees.